It's blowing up.
Could you feel the impact?
No, it knocked me about 30 feet.
On the day of the disaster, a team of workers was assigned to routine maintenance on Reactor 6.
And you just got up and started running?
A 150-foot tall loop reactor responsible for producing high-density polyethylene, the same plastic used in bottles and everyday containers. Inside that enormous vessel, a volatile cocktail of ethylene, isobutane, hydrogen, and hexene was pushed to its limits, 230 degrees and 600 psi, to create HDPE particles. Those particles settled into 6 legs, long pipes that regularly clogged and had to be cleared manually, all while the reactor continued running at full pressure. It was a job workers had done countless times. But on this day, something was different. Cleaning didn't begin until all 6 legs were completely blocked, and that happened on Sunday, October 21st. The crew followed the usual steps. Close the isolation valve, confirm the indicator showed closed, disconnect the air hoses, and physically lock the valve shut. Everything looked correct, but the cleaning was postponed due to other, higher priority work. And that one scheduling change would set the stage for one of the deadliest industrial explosions in U.S. history. What happened next took investigators months to reconstruct. On Monday, October 23rd, without warning, 99% of the reactor's content, 885,000 pounds of flammable gas, escaped in seconds. A massive vapor cloud formed instantly and swept across the plant grounds like a racing storm. A warning siren echoed through the facility. Workers ran, but they had only seconds. Within 2 minutes, the invisible cloud hit an ignition source. The result was a devastating explosion, equivalent to 2.4 tons of TNT, registering 3.5 on the Richter scale. Metal rained from the sky. Structures collapsed. Workers were thrown dozens of feet. What followed was chaos. The blast ignited nearly the entire complex. Within minutes, flames reached 2 20,000-gallon isobutane tanks, triggering a second massive explosion. Another HDPE reactor exploded 45 minutes later. Possibly 3 more followed. Phillips's internal fire brigade responded first, but the scene was already beyond control. Much of the firefighting water system had been destroyed in the blast. Crews were forced to pump water from cooling towers, neighboring plants, even the ship channel. For 10 brutal hours, firefighters, foam crews, and mutual aid teams battled infernos fueled by thousands of gallons of chemicals. Search and rescue, impossible. At least until the next morning, when the fires finally calmed enough for OSHA and plant officials to enter the twisted ruins. What they found was worse than expected. Investigators discovered that during maintenance, the physical lockout device on settling leg 4 had been removed. Workers then reattached the air hoses, but because both hoses were identical, they could be easily swapped. If reversed, the control valve could appear closed, while actually standing wide open. That single design flaw allowed reactor contents to escape uncontrollably. OSHA uncovered an alarming pattern. Known safety hazards had been documented internally, but not corrected. Backup safety systems were missing. Air connections could be engaged during maintenance. Buildings were spaced too closely together. Trapping workers, less trained subcontractors performed hazardous operations. The result? 22 workers killed, with 1 more dying later in the hospital. Another 130 injured, including dozens burned or trapped. over $715 million in damage, and nearly the same amount lost in production. OSHA issued 566 willful and 9 serious citations, one of the largest enforcement actions in the agency's history. Phillips eventually paid a $4 million fine and agreed to implement nationwide process safety management protocols. But the lessons came at an unbearable cost, and shockingly, the plant suffered fatal explosions again in 1999 and 2000. Proof that safety reforms on paper mean nothing unless they are implemented every single day. This disaster didn't happen because of a single mistake. It happened because of layers of ignored warnings, flawed design, and broken procedures. Each one small, each one survivable, until they lined up. In industrial safety, that alignment is all it takes. If you found this breakdown insightful, drop a like, share your thoughts, and watch the next Safeline investigation.